back. Today we're going to talk about section 6.3 and 6.5, which is basically properties of parallelograms and special parallelograms. Just to review, last unit we talked about, we're kind of introducing all quadrilaterals, and we talked about the trapezoid and the kite. Today we're going to talk about all the quadrilaterals that involve parallelograms and their special parallelograms. Okay. So first of all, parallelogram, all the properties of a parallelogram. First of all, the opposite sides are parallel. So opposite sides of a parallelogram are parallel, and this creates unique situations. If you remember back to our properties of parallel lines and transversals, we have special properties. Okay, and that creates corresponding interior angles that are supplementary and so forth. Opposite sides are also congruent. Okay, in this case. So over here, because we have those parallel lines, we have opposite angles that are congruent, and then we also have consecutive angles that are supplementary. So these consecutive interior angles here are add up to 180, and E and F add up to 180, and all the way around. And our opposite angles are equal. Our diagonals are also bisect each other, so they cut each other in half. Okay, so we're going to put some of those properties to use here. We have a parallelogram here, and we want to find the value of x. Well, since we know that opposite sides are congruent here, we know that this side is congruent to this side, and over here is congruent over here. We can use that to set those expressions equal to each other. I'm going to use probably these two guys because that's a monomial, so it's going to be probably the easiest. So I know that 4x equals 5x minus 3, and I can just solve for x. So I'm going to subtract x, or excuse me, 5x. And I get negative x equals negative 3, which means that a positive x equals a positive 3. And that is my value for x. Part B here says, what are the lengths of each side of the parallelogram? Well, if I plug in 3 here, I get 4 times 3. That's a 3, which gives me the length of 12 for this side. And if that's 12, this opposite side is also 12 because they're equal. If I plug in 3 down here, so 2 times 3 plus 12, that gives me a 6 plus 12, which means that side is, whoops, I get ahead of myself here, 12. That means this side is 18, which means my opposite side is also 18. Okay, so those are all the lengths of my sides of that parallelogram. All right, let's take a look at some angle measures now. Given this parallelogram, what are the measures of angle A and C? Well, I know that if D is 114, A and D are supplementary, right? And so if I take 180 and I could subtract 114, that should give me my 66 degrees, which should be angle A right here, 66 degrees. Angle B is the same as angle D because they are opposite. So this should be the same as angle D, which is 114 degrees. Okay. So use the parallelogram here. Now this time we have consecutive angles, and so we know consecutive angles are not equal, only opposite ones are, but they add up to 180. So I know that I'm going to take my A plus 5 angle here, plus my 8a minus 5 angle here, and that should add up to 180. They're supplementary, okay? Then I can combine like terms. A plus 8a is going to be 9a. My 5s get canceled, and that equals 180. So I divide by 9. My a should equal 20. That's my value of a. What are measures of angle G, H, J, and K now? Well, if I take my A and plug it into here, so this should be 20 plus 5, which would give me 25 degrees, right? I know these are supplementary, so this is going to be 180 minus 25 degrees, which that should be 155, right, for that one. And this one would be also 155 because it's opposite, and this should be also 25 because it is opposite as well. Right, so those are some properties of my parallelograms. Let's look at the diagonals. So use this parallelogram RSTU. SU is 35, so that's the whole length across here. And KT, so just this little one right here, is 19. Okay, what is SK? So if the whole thing is 30, this whole thing SU is 35, half of it will be half of 35. So 35 divided by 2 will be 17.5. So SK right here will just be 17.5 right here. What is RT? So if half of this KT is 19, then the whole thing will be 19 times 2 right here, which would be 30 8. And that will be the length of that diagonal because they cut each other in half. Okay? Okay, so let's get on to our special parallelograms. So all of these here are parallelograms. We have a rectangle, which is just basically a parallelogram with 4 right angles. We have a rhombus, which is a parallelogram with 4 equal sides. And then we have a square, which is a parallelogram with both of those, 4 equal angles and 4 equal sides. So a square technically is both a rectangle and a rhombus. Okay, so it belongs to both categories. All right? So looking at a rhombus, all the characteristics of a rhombus have everything the parallelograms have, right? The diagonals bisect each other. They have parallel opposite sides. They have, supplementary angles that are congruent. They have opposite angles that are, consecutive angles that are supplementary, opposite angles that are congruent, so forth and so on. But then they have these additional, okay? All sides are congruent, so that's something that's additional to a parallelogram. All diagonals bisect opposite angles. So you'll see over here, the diagonal right here bisects K and bisects M. The other angle also bisects its opposite angles, okay? And then the diagonals are perpendicular. So see right here where the diagonals cross at a 90-degree angle. Okay, so those are the additional properties of a rhombus. So let's look at some of these. So if this is a rhombus, what are the measures of angles 1, 2, 3, 4? Well, we know that a rhombus intersects at a 90-degree angle, so all of these will be measuring 90 degrees, every single one of them. Okay? What is WY? So this whole length right here. Well, if this is 3, this will have to be 3, right? This is 90 degrees, so we can actually use the Pythagorean theorem to find out what this length is right here. Okay? And so we could take and do our 3 squared plus x squared equals 5 squared. Right there. And we get 9 plus x squared equals 25. And we're just going to subtract our 9. X squared equals 16. And we'll take the square root, x equals 4. Okay, so this is 4. Well, if that's 4, WY is the whole thing, so we're going to double it right here. So WY is equal to 8. Okay, so don't forget your Pythagorean theorem. Okay, here's quadrilateral ABCD. It's a rhombus. What is the measure of ADE? So we're talking about this angle right here, ADE. All right, so right here, this is a 90-degree angle. We know this angle gets bisected by its diagonal, so this is 53 degrees, and now we can use a triangle sum. We know that 90 plus 53 plus x should equal 180 degrees, right? So this should be 143 plus x equals 180. Whoops, 143 here. So x should equal, what's that, 37 degrees. Okay, that's a measure of ADE. Okay, so here's a quadrilateral. It's a rhombus. What is GH? So the length right here. So first of all, we have to find out what x is. I know that GH is also 3x plus 1. Right? This is also 3x plus 1 because they're equal. So I know that these two are equal because they're diagonals that bisect each other. So 2x plus 3 equals 4x minus 7. So I'm going to subtract 2x from both sides here. So 3 equals 2x minus 7. And go ahead and add 7 to both sides. So we get 10 equals 2x. And divide by 2. So 5 equals x. So now that I know what my x is, I can plug this in up here. So 3 times 5 plus 1, which gives me 15 plus 1, which is 16, is my length of my GH, is 16. Okay? All right, we're cruising right along with these properties here. And the quadrilateral is a rhombus right here. What is MNO? So we have MNO. So it's this big angle right here. We want this whole angle. Okay, so if this one's 62, we know that this one must be 62 also. And we know that this intersects at a 90-degree angle. So we can find out what this little angle is over here. I'm going to make this red. So we can find out what this angle is right here. Okay, so we go 90 plus 62 plus x should be 180 degrees, right? So 152 plus x equals 180 degrees. So we're going to subtract 152 from both sides. So x is going to be 28 degrees right here. Or sorry, yeah, just 28. Right here's 28. So that means that this one is also 28. So that means that MNO is equal to 28 plus 28, which would be 56 degrees. Okay? So it's like putting little pieces of puzzle together with these things. Okay, now we have a rectangle. So a rectangle has everything a parallelogram does. All the opposite sides are parallel, opposite sides congruent, so forth and so on. And then we add on to that all my angles are congruent. They're all 90 degrees. And my diagonals this time are congruent also. Okay, so let's take a look at this. What is the length of RN? It's my diagonal. Well, I know if all my diagonals are congruent and they bisect each other, these must be equal, right? So that's going to be 3x plus 1 must be equal to 2x plus 4. So I'm going to subtract 2x. X plus 1 equals 4. Whoops, there we go. Minus 1. X equals 3. Right here. Okay. So Rn, if we put 2 times 3 right here, plus 4, that's going to give me 6 plus 4, which is 10. Whoops, there's 10. This must be 10 also, which means Rn is going to be equal to 20. Okay? So again, just kind of like a little puzzle we have to put together. So here's a good one that involves area. So we have a rectangle that has an area of 1,600 meters. It's 4 times as long as it is wide. So if you think about my width is W, that means my length is going to be 4 times W. So it's 4 times as long. Okay? So I know that, so then my length, which is W times my width, or I guess my W times 4W, is equal to 1,600 meters squared. So that's length times width. Okay. So that's going to give me my 4W squared equals 1,600. Let's solve for that W, see if we can find out what our width is. So W squared equals 400. Take the square root. W equals 20. Okay, so if W equals 20, 4 times W equals 80. Okay, well, they want us to find out what is the sum of the diagonals. We'll just find out what one diagonal is, right? So if this is 80 here, and this is 20, what I'm going to do here is I'm going to use my Pythagorean theorem again. So I'm going to find the length of my diagonal here, that's 90 degrees. So I'm going to find out what x is here. Okay, so I'm going to take 20 squared plus 80 squared. That should give me my diagonal squared, my x squared. Okay, so I have 400 plus 6,400 equals x squared. That will give me 6,800 equals x squared. And I got to take the square root of both of that. And I had that on here somewhere. Let me see if I can find it. So the square root of 6,800 is about 82.5. Well, I'm going to call it 82.46 is approximately what my diagonal is. So 2 of my diagonals, where I'm going to add the sum of them together, I'm going to multiply that by 2, gives us about 165. I'm going to put a little, actually approximately equal to 165. Okay, so that's what my sum of my diagonals are, is about 165. Kind of 2 problems in one there. Get your worth your money. So now a square is all of them. It has all the properties of parallelograms and all the properties of rectangles and rhombuses. Okay, so all my angles are congruent, all the sides are congruent, all the diagonals are congruent, the diagonals are perpendicular, the diagonals bisect opposite angles, they bisect each other, all of it. It gets all of the cool stuff. Okay, so figure x, w, x, y, z is a square. If wy plus xz, so the diagonals add up to 92, what's the area of this little blue shaded region? WPZ, okay? Well, if my diagonals are 92, what's 1/2 of them? Okay, so 92 divided by 2 is going to be, what is that, 46? So length of 1, we're going to just say wy equals 46. Well, I want to have just one of these lengths right here, so I'm actually going to divide 46 divided by 2, and that's going to give me 23. Okay, so this is 23 right here. This is 23 right here. and this is a 90-degree angle. Well, now I can find my area, right? So my area is going to be, if you remember, 1/2 my base times height. So this is my base, that's my height. My base and height are always perpendicular. So 1/2 times 23 times 23. So my area is going to be, let's put that in there. So 1/2 times 23 times 23 gives me 264.5. And there you go. That's the area of that one little blue region right there. All right, almost finished. A square has diagonals AC and BD. What is the measure of ABD? So first of all, draw yourself a picture always, okay? Label it. And polygons are always labeled in order of the letters. So A, B, C, D, it goes around. It doesn't go jump around. It goes all in order. It doesn't matter if you go clockwise or counterclockwise, okay? And I'm going to draw my diagonals. It should fit, right? AC should line up, and BD should line up. Okay, so what's the measure of ABD right here? Well, we know that the squares have 90-degree angles, so that should be half of that because it gets bisected. So a measure of angle ABD is going to be 45 degrees, which is 1/2 of that angle because it gets bisected by its diagonal. Okay? All right, so here's a summary of all your parallelograms. Here's a summary of all your special parallelograms. You guys have an assignment in the Excel. It's a playlist of 2 Excels together. And so just be aware of that. Be sure to attach all of your work and answers. And I will see you all next week. Have a wonderful weekend, and I'll talk to you later. Bye-bye.